So this video is going to be devoted to net ionic equations, and only 3 of them, so I get to talk a little bit more slowly. So let's look at the first one. The first thing you have to do is complete your double replacement reaction, which shouldn't be too bad at this point. So I'm going to combine PB and Cl, and I'm going to combine Na and NO3. Now remember, I'm just concerned about the identity of the elements. I'm not concerned about the little 2 there, right? So PB has a +2 charge, and I get that because I can uncross my charges. Okay, so this is +2 now. This is -1. So I cross my charges, PB2 plus Cl minus 1, and I got PbCl2. I do the same thing with Na and NO3. And notice I'm ignoring that little 2 right now because I don't care. Na is +1, NO3 is -1, so I write NaNO3. Now I can deal with that little 2 by saying, okay, well, I've got 2 NO3s, so I need to put a 2 here to balance it. Now I've got 2 NAs, so I need a 2 there. And I've got 2 Cls here, but I wanted that anyways. Next step, guys, is to look at your chart on your cheat sheet and decide what's soluble and what's insoluble. So all nitrates are soluble, so that's soluble. Anything with Na is soluble. PbCl2 is one of the exceptions for Cl, so it's insoluble, and NaNO3 is soluble. So anything that's soluble, you break up into its ions. Anything that's insoluble, you leave alone. So I've got Pb2 plus 2 NO3s. Now don't put the subscript 2 there, that's wrong. I'm just talking about how many NO3s I have. So it's 2 NO3, and the charge is minus. Don't be forgetting charges or else I have to take off. Plus 2 Na pluses plus 2 Cl minuses. Gives me, this is insoluble, so I leave it alone, plus 2 Na pluses plus 2 NO3 minuses. Now anything that's the same on either side, I get to cross out. So I cross out my NAs and I cross out my NO3s. Now if there weren't a 2 here, for example, don't not cross it out. Recognize the fact that you forgot to balance and go back and make sure you balance. Okay, so I got PB2 plus 2 Cl minus gives me PbCl2. My spectator ions, right, the ones that were crossed out that had nothing to do with the actual reaction, was NO3 minus and Na plus. So in a lab, like what we did in class, what you would see if you saw a precipitate form, the reason why it forms is because you have this reaction happening, and the identity of that solid is PbCl2, for example. Okay. If you see no reaction, guys, that means that everything was soluble, and therefore no reaction happened. And it was actually a physical change. It wasn't actually chemical, right? Because you don't have anything actually changing identity. All right. B, I'm going to have Fe and OH together. I'm going to have Na and Cl together. So Fe has a +3 charge. You get that from looking here, not at your periodic table. And then OH has a -1 charge. So when you cross charges, guys, you get Fe in parentheses OH, close your parentheses, 3, plus Na and Cl, it should be NaCl, because Na is +1, Cl is -1. I balance, there's my balance, and then I find what's soluble and what's insoluble. Well, FeCl3 is soluble, that's insoluble, and that's soluble. So let's do this. Fe has a +3 charge, so Fe3 plus I have 3 Cl minuses, so it's 3 Cl minus, plus 3 Na pluses, plus 3 OH minuses. Gives me FeOH3 plus 3 Na pluses plus 3 Cl minuses. So don't forget the 3's and the minuses and the pluses, because then I'll take off and you'll be sad. Alright, so you're going to cancel out your Cl's, cancel out your NA's, and so what you end up with is Fe3 plus 3 OH minus, which gives you FeOH3. Your spectator ions, the ions that actually didn't change at all, are Na plus and Cl minus. Alright, let's do the last one. For C, NaCl and AlNO3, Na goes with Na goes with NO3, sorry. So Na is +1, NO3 is -1. Cross your charges, this is NaNO3. Then you combine Al and Cl, Al is +3, Cl is -1, so AlCl3. You balance, and what you notice, guys, when you're looking up your solubility rules, this is soluble, that's soluble, that's soluble, and that's soluble. So, do you not have to write a full ionic? Not at all. You have to write a full ionic. Now, you don't have to write a net ionic. Okay, so it's going to be 3 Na pluses plus 3 Cl minuses plus Al plus 3 NO3 minuses. Gives you 3 Na plus 3 NO3 minus. I forgot that my minus. I know that. I'm sorry. Okay, plus Al3 plus 3 Cl minus. Now, notice, other than the fact that I made a mistake, and I'll correct it right now, and I need a minus there, everything's going to be the same, so everything cancels, so my NA's cancel. My NO3s cancel. My ALs cancel. My 3CLs cancel. And therefore I have no reaction. Okay? That's like in the lab, guys, when you did all 5 of the reactions and one of them you didn't see anything at all. That's because everything was soluble. So nothing became a precipitate because nothing was insoluble. Now the spectator ions, guys, are going to be all your ions because none of them are doing anything, right? They're just watching. Well, they're not really watching anything because nothing happened. So the ultimate question I could ask, and I will ask so I know who's watching this and who's not, is what type of change happens in this reaction? Is this actually a chemical reaction? And what your answer should be is no, because nothing actually changes. This is the exact same thing as this. Nothing's insoluble, nothing changes identity, so therefore this is going to be a physical change. Okay? And that's it, guys. That's all I've got for you. Study hard.